Hello, welcome to another episode. In this episode we're going to have a look at the Disassembly debug window. What is it and how can it help us improve our assembly coding? Let's say you're new to writing assembly code, but you're already familiar to writing C code. Wouldn't it be nice to write a little C program and then check how the C compiler has translated this into assembly code? I will show you how to do this in this episode. Here you see a small C program that just prints 3 strings like this. In this episode we will be calling printf from assembly code, so you might want to check out episode 10 for more details. And if you are new to programming assembly code in Visual Studio, please check out episode 1. Okay, let's start. It is important that you do a release build of your code, but to show you why, I will first do a debug build. We start the debugger by pressing F5. Now we open the Disassembly window by going to Debug, Windows, Disassembly. You can also press Ctrl-Alt-D. In the Disassembly debug window we can see the C code in white and the compiler generated assembly code in gray. Now the problem of building for debug is that the compiler generates a lot of assembly instructions just for facilitating C debugging. We are only interested in seeing the assembly instructions required for our little C program, so we will try again with a release build. Press F5 again to start the debugger, and let's see what we have in the disassembly window. You can see the C code in white and the assembly instructions in gray. And now we see that after doing the release build, we have fewer assembly instructions. Let's have a closer look at the assembly instructions generated by the C compiler. First, the register RBX is pushed onto the stack. In this register, the value of the num variable will be stored. Later, this register will be compared to the value 3, and based on the result, the code will be repeated or not. This implements the for loop. At the end, we will need to get the original value of RBX from the stack. Why is register RBX used here? This is because RBX is a non-volatile register. This means that the printf function is not allowed to change the value of RBX, because that would break our code. But our code is also not allowed to change the original value of RBX. That is why the value of RBX is first pushed to the stack and later retrieved from the stack. The sub and the add instructions are reserving stack space for the printf function. For more details, check out episode 9. The XOR instruction is used to clear the register EBX. Only a 32-bit register is used because our C program only uses a 32-bit variable. Next we have an interesting instruction. The NOP instruction actually doesn't do anything, and NOP stands for no operation. The only thing it does here is adding 2 bytes to our code. And this is probably the reason why the C compiler decided to add this instruction. Here you can see a conditional branch instruction that might jump back to this address. And what the NOP instruction has done is to make this address 16-byte aligned, or even 32-byte aligned. And this is probably an optimization related to the instruction cache. Next, we move the value of num, which is in register EBX, into register EDX. We do this because printf expects the parameter to be in RDX. Printf also expects that the format string is in register RCX. After this we can call the printf function. The value of EBX is incremented, just like we do in our C code here. Then we compare register EBX to the value 3, which we do in the C code here. If the value of EBX was lower than 3, we need to jump back to this address. And when the value was 3, we exit the for loop. Register EAX is cleared because our main function uses it to return 0. The add instruction frees up the stack space reserved for the printf function. And the pop instruction retrieves the original value of RBX from the stack. That was pushed to the stack here. And now we reach the end of our little C program. I think using the disassembly debug window like this is quite useful. It can help us if we don't know how to implement something in assembly code. And it is also quite interesting to see how the C compiler generates assembly code. Go and have a try for yourself. Thank you for watching. Please help my channel grow by subscribing and liking my videos. Hope to see you in the next video.